and welcome to section 7.5, the techniques of integration. So this lecture is going to be a little bit different. There are no notes that go with this lecture, mostly because there's not really new content here. So in section 7.5, we just kind of group together all the integrals that we've been working on. So I just want to talk a little bit and remind you of things we've been talking about for the last few weeks and collect it kind of all in one place. So first of all, we have 5 techniques that we've been working with. We have integration by parts, we have U substitution, back from chapter 5. We have trig integrals. We have trig substitution. And we have partial fractions. Okay, now 3 of these are very particular in the structure of the integral in which you would use it. And that's particularly talking about these last 3. So we talk about these last 3, there are particular instances where you would use those. Okay, so let's talk about what that is. So first of all, number 1, when you have a polynomial divided by a polynomial, something like, for example, the integral of x plus 2 over x squared plus 5x minus 6 dx. Okay, whenever you're seeing something like this, typically we're working with partial fractions. Right, so partial fractions goes here. All right, and so you're going to break things down. So you're either going to look at the degree of the numerator, degree of the denominator. If the degree of the numerator is equal or higher, then you're going to divide through first. Otherwise, you're going to try to factor that. That one goes probably with x plus 6, x minus 1, right? And you're going to decompose your fractions. So polynomial divided by polynomial is partial fractions. Okay, only time we use that one. Number 2, when you have all trig functions. So for example, something like the integral of sine squared x cosine x dx, right? In that case, we're talking about trig integrals. Bring that down here. So this is when we use our trig integrals, right? And you've got different strategies here. If you a lot of times you're going to go to sines and cosines and then take a look at what's happening, right? We know if it's even or odd, what we do, right? And typically if we've got a denominator, whatever's in the denominator is typically going to be my u, right? In this case, I would probably make my, in this particular one, this would be my du, which means my u would be sine x, and my du would be cosine x dx, right? But all the things we talked about in section 7.2 for trig integrals. The third is when you have something like the square root of a squared x squared minus b squared, square root of a squared minus b squared x squared, or the square root of a squared x squared plus b squared. And anytime when you're in that situation, this is trig sub, right? So that's coming down here, right, as our trig sub. And we know that we're going to be making a trig sub for either secant, sine, or tangent, depending on what's going on, right? This one here, to be specific, right? For this one, we would let our x be equal to b over a times the secant of theta. The middle one, our x is going to be a over b sine theta. And this last one, we're going to have x equals b over a tangent theta, right? We talked about that in section 7.3. And so that leaves by parts versus u sub. Okay. The difference here is that for u sub, we're looking for a function and its derivative. If you don't have that, then you're going by parts, okay? Particularly if the functions look different. So different types of functions being multiplied. And by that, I mean something like the integral of x times the cosine of x dx, right? The x and cosine, different types of functions. E to the x times the square root of x plus 1, right? Different types of functions. Any of these things would be your by parts, okay? Things that would be u sub, things like ln of x over x dx, right? Versus something like x ln x dx would go over here. Why? Because this one can be separated as the integral of 1 over x times the natural log of x dx. And then you have a function and its derivative, okay? So I would u sub. Over here, you have a function, but x is not its derivative. So that's not going to work out for me. You're going to have to go by parts, okay? A lot of times I try a u sub, and if it doesn't work, then go by parts, okay? Typically, when you're u subbing, you want to look for something with where there's grouping symbols. So something with inside parentheses under a square root as the argument of a trig function or an e or an ln, right? Something that's inside something else. Or maybe the denominator of a fraction, those kinds of things. You want to make those your u's, okay? Also, if you take a look in the section of the book for 7.5, you're going to find a chart, right? And a chart of integrals, which is a nice resource. But to be honest, we've actually done pretty much all of those. The only things I don't think we've done is the hyperbolic trig functions, which we are really not that concerned about. Unless you're doing some high-end physics or differential equations, you're not going to be looking at Sinches and Cauchys. So we can kind of skip on those. All right, but that's it for today's lecture. We're just practicing more integrals and trying to nail down when we use which type.